Hello and welcome to the latest DPA video interview. Today I'm with Mark Checkley, who is the Sales and Marketing Manager at KEB UK, a company which provides advanced automation solutions for industry. We will be discussing the subject of high-speed motor and drive applications and the challenges that these give. So, Mark, what do you define as high speed?
It's really defined by the application. You've got routers that run at 22 to 30,000 RPM, high-speed blowers and compressors, and they run at 40, 50 and up to 60,000 RPM, mainly moving air around, but that's changing and becoming into liquids as well. And then slightly more specialist applications run at 90, and we've seen them run up to 120,000 RPM.
What are some of the issues that people attempting high-speed applications face?
It really falls into four main ones that are worth mentioning. The first one is when you're running above the base fundamental speed, and that's called going into field weakening. So that's when you've got a motor that's rated at 60,000 RPM and you want to run it at 70,000 and the issues that involves.
Okay.
The next one to consider is the heating effects of the stator and the rotor within the motor. And this is determined by the quality of the sine wave that's being fed into it to drive it. Another main one is feedback devices. If you've got a feedback device on there used to maintain speed stability, you've got the issues that come up with vibration at the high speed, and also the amount of data that's coming back as it's done on per revolution. And then the other issue that people often come up against is the type of motor that they're running. They often choose different non-standard motors, and they're not always compatible with the drives that they want to use.
So how does KEB deal with these issues? Is it mechanically or digitally?
The answer is a bit of both. So if I go through each one, so in what we call running in field weakening, this is done electronically. It's done through the control of the magnetizing current going to the motor, and that's controlled within the actual drive itself. The heating effects is a bit of both. So the one is mechanically, and that's done through sinus output filters. This is something that we design and build at KEB in our German manufacturing plant. So we can then select the most optimum unit to run with the actual application that a customer has. Now this will give you a really smooth, clean sine wave, and that reduces the heating effects in the rotor and the stator. Done in conjunction with that is the electronics inside the drive, and this is we're able to run at the switching frequency right up to 16 kilohertz, which will again affect the heating, reduce the heating within the motor. It transfers it more onto the drive. And what we're also able to do to enable us to run at the high speeds is go above the 599 hertz, which is a limiting factor legally. Provided the right criteria is met, we're able to unlock that and drive that much higher. Going on to the other two issues, one was the feedback devices. With the electronics within the drive, we're able to run these sensorless, all the motors sensorlessly. So that's ASCL and SCL. We've done articles on that, and it's probably a topic for another subject. What we can do is then completely eliminate the feedback device. So all the issues are just gone away. And then the last one that I mentioned was the types of motors. Our drives with all the electronics inside of them are able to run all types of motors, whether they be synchronous, asynchronous, variable reluctance, permanent magnet, to name four. We can drive all of them with the electronics in there. So again, that's not an issue for the customer.
Okay, so going forward, will there be an increased need for high-speed solutions?
There will continually be a need for high-speed solutions because of the applications are needed. We're seeing an increase in the projects for them because people aren't able to solve them using other people's products or support that they've got. This has also led on to other applications, some high-speed, some not high-speed, that we've been able to do. So we've seen an increase in turnover and demand for these type of applications.
Fantastic. Thank you very much, Mark. To find out more about the solutions offered by KEB, please go to their website. And if you have any questions relating to the topic discussed today, please contact Mark. All these details will pop up on the screen shortly. Thank you very much.
Thank you.